So all along, we've been looking at partial derivatives of functions with respect to x and y, and these basically represent the rate of change of the function as 1, x is made to vary, and then y is held constant, and then 2, y is made to vary, and then this time x held constant. Now these basically represent fx and then fy respectively. So in this lesson, we are going to discuss how to find the rate of change of a function, this time when both x and y are made to vary simultaneously. So recall that if z is said to be a function of two variables, that is z is equal to f of xy, then we have fx to be the partial derivative of the function with respect to x, and then fy also being the partial derivative of the function with respect to y. Now fx in terms of limits is given by the limit as h approaches 0 of the function f of x plus h, comma, y minus f of xy, all divided by h. Now this basically represents the rate of change of the function when it's being directed along the x-axis. The rate of change of the function directed along the x-axis, and then fy, which is the partial derivative of the function with respect to y, is said to be, in terms of limits, the limit as h approaches 0 of the function f of x, comma, y plus h minus f of xy, all divided by h. And this is also said to be the rate of change of the function when it's directed along, this time, the y-axis. Now suppose that we wish to find the rate of change of the function with respect to an arbitrary unit vector. Then basically we are talking about directional derivatives. So we say that the directional derivative of a function at a point xy in the direction of an arbitrary unit vector u cap, which has components a, b, is said to be given as, so we have du f of xy, which is the directional derivative of the function, and that is given by, in terms of limits, the limit as h approaches 0 of the function f of x plus ha, comma, y plus hb minus f of xy, all divided by h. Now notice that a and b here are basically the x and y components of the unit vector u cap. Now if the directional derivative is directed along the x-axis, if it is directed along the x-axis where we have the unit vector, let's say u cap x is equal to I, then in terms of components we say that this is equal to 1, 0. Now if this is the case, if the directional derivative is directed along the x-axis, then we say that the directional derivative of the function is equal to the partial derivative of the function with respect to x. So if we substitute 1, 0 in place of ab in this limit, then we are going to have the left hand side being equal to fx. And then similarly, if the directional derivative of the function is directed along the y-axis where we have the unit vector along the y-axis being equal to j, which is given as 0, 1 in terms of components, then we have du of f of xy being equal to fy, which is the partial derivative of the function with respect to y. So in this case, we can say that fx and then fy are just special cases of the directional derivative. Now the directional derivative of a function at a point xy in the direction of an arbitrary unit vector can as well be represented as du f of xy equals the partial derivative of the function with respect to x times a plus the partial derivative of the function with respect to y times b. And then notice that a and b are the x and y components of the unit vector. Now we have a question here, that is question 1. We are asked to find the directional derivative if f of xy is equal to x cubed minus 3xy plus 4y squared in the direction of the unit vector given by the angle theta equals pi on 6. And then we are asked to find or determine the directional derivative of the function at the point 1, 2. So how do we solve this? So first of all, we know that the directional derivative of the function is given by fx times a plus fy times b. So let's try to find fx and then fy. So we have the function f of xy, and that is given by x cubed minus 3xy plus 4y squared. Now fx is the partial derivative of the function with respect to x. So we are going to differentiate this function with respect to x, and then we treat y as a constant. So we differentiate x cubed, we have 3x squared, and then we have negative 3y as constant. We differentiate x, we have 1, and then here we differentiate 4y squared, and then we have 0. So this basically is equal to 3x squared minus 3y. So that is for fx, and then for fy we are going to differentiate this same function, this time with respect to y, and then we treat x as constant. So we differentiate x cubed, and then we have 0 minus 3x, that's the constant, and then we differentiate y so that we have 1, and then plus we differentiate 4y squared, we have 8y. So this is equal to, we have negative 3x plus 8y. So this is also fy. Next, we need to find a and b, or better still, the unit vector. Now the unit vector is given by the angle theta equals pi on 6. So we say that u cap, which is the unit vector, is equal to cosine of the angle pi on 6, comma sine of the angle pi on 6. Notice that the unit vector is given in terms of an angle, that is theta. Therefore, if you want to find the unit vector u cap, then basically that is equal to cos theta, comma sine theta. Therefore, we can evaluate this so that we have, now cos pi on 6 is the square root of 3 divided by 2, and then sine pi on 6 half. So this is the unit vector. Therefore, we have a to be equal to root 3 over 2, and then b to be equal to 1 over 2. Therefore we have the directional derivative of the function f of xy to be equal to, so we have fx, which is 3x squared minus 3y, all times root 3 over 2 plus fy negative 3x plus 8y, all times 1 over 2. Now notice that we have 2 appearing here and then here at the denominator, so we can pull that one out. So we are going to have 1 over 2 outside, and then we multiply root 3 across for this term. So we are going to have 3 root 3 times x squared minus 3 root 3 times y, and then here we have negative affecting this term, so this becomes minus, we multiply 1 across, so 3x plus 8y. Now we can simply group like terms so that we have 3 root 3 times x squared, and then minus 3x, and then minus 3 root 3 times y plus 8y. So basically this is the directional derivative of the function at the point xy. Next, we are asked to find the directional derivative of the function at the point 1, 2. So basically we are going to substitute 1, 2 in place of xy. Therefore, we have du f of 1, 2, and that is equal to, now from this expression, we have 1 over 2 into brackets, so 3 root 3 times, we have x is equal to 1, so 1 square minus 3 times 1 minus 3 root 3 times y is equal to 2 plus 8 times 2. So we have 1 over 2 on the outside. This becomes 1 square is still 1, so we still have 3 root 3 minus 3 minus 3 times 2 is 6, so 6 root 3, and then this becomes 16. Now here we are going to add or subtract like things. So we have 3 root 3 minus 6 root 3. So 3 minus 6 is negative 3. So negative 3 root 3. And then negative 3 plus 16, that becomes positive. So positive 13. Therefore, we have the directional derivative at the point 1, 2 to be equal to half times into brackets negative 3 root 3 plus 13. Now let's move on to the next question. So for question 2, we are going to find the directional derivative of the function in the direction of u and also determine the directional derivative at the point 3, 1, 0. Now again, looking at this question, you realize that we are not given the unit vector, or better still the unit vector in terms of angle. We are literally given the direction vector u, and so we need to find the unit vector. So we have the unit vector, which is u cap, and that is equal to the direction vector divided by its magnitude. So we have negative 4, 4, 2 divided by, we have the square root of negative 4 square plus 4 square plus 2 square. So we have negative 4, 4, 2 divided by the square root of, now negative 4 square is 16, 4 square is 16, and then 2 square is 4. So thus we have negative 4, 4, 2 all divided by 16 plus 16 is 32 plus 4 is 36, and then square root of 36 is 6. Therefore, we have the unit vector having components negative 2 over 3, 2 over 3, and then 1 over 3. So this is the unit vector. Again, we should understand that because this is a function of 3 variables, the directional derivative, that is du f of x, y, z, is given by fx of x, y, z times a plus fy of x, y, z times b plus fz of x, y, z times c. So basically we need to find fx, fy, and then fz. So for fx, we are going to differentiate this function with respect to x, and then we consider y and z as constants. So we differentiate for x, we have 4 minus y square is a constant, so we are going to differentiate this function e to the power x square. So we differentiate the exponent with respect to x, and then when you differentiate x, you have 1 times z is z, so we drop down z, and then we have e to the power xz. and thus this is equal to 4 minus y square z e to the power xz. Now for fy, we differentiate with respect to y, x and z are constant. So we differentiate this, that is the constant, we have 0 minus e to the power xz is constant. We differentiate y square, we have 2y, and thus we have fy equals negative 2y e to the power xz. Next to fz, that is equal to, we differentiate this with respect to z, x and y are constant. We differentiate this, we have 0 minus, we keep y square as constant, we differentiate this function. So we differentiate z on top, and thus we have 1 times x is x. So we have x times e to the power xz, and thus we have fz to be equal to negative x y square times e to the power xz. So this is fz. Now we are going to, using this formula, we are going to input the expressions for fx, fy, and then fz, multiplying each of them by a, b, and c, the components of the unit vector. Therefore we have the uf of x, y, z to be equal to, so fx, that is 4 minus y square z e to the power xz, all times negative 2 over 3, that is a, and then plus fy, negative 2y e to the power xz, all times 2 over 3, and then plus fz, negative x y square e to the power xz, all times 1 over 3. So we have a common denominator, that is 3, so we can pull out 1 over 3 outside. We multiply negative 2 across this term, so this becomes negative 8, negative plus 2 y square z e to the power xz, and then this minus 4 y e to the power xz, and then minus x y square e to the power xz. Therefore this is the directional derivative at the point x, y, z. Now we are asked to find the directional derivative at the point 3, 1, 0. So we have x to be 3, y to be 1, and then z to be 0. Therefore the uf of 3, 1, 0 is equal to, we have 1 over 3 on the outside, negative 8 plus 2 times y is 1, so 1 square, and then z is 0, e to the power x is 3, z is 0, minus 4y is 1, e to the power x is 3, z is 0, minus x is 3, y is 1, so 1 square, times e to the power 3 times 0. So here we have 0 times everything here, so this term goes to 0, and then e to the power 0 is 1, 1 times negative 4 is negative 4, e to the power 0 is 1, 1 times negative 3 is negative 3. So this is equal to 1 over 3 times negative 8 minus 4 is negative 12, minus 3, negative 15, and then 1 over 3 times negative 15 is equal to negative 5. So the directional derivative at the point 3, 1, 0 is equal to negative 5. Now let's move on to the next and the final question. So for question 3, we are going to find the directional derivative of the function f of xy equals 1 plus 2x times square root of y in the direction u equals 4, negative 3, and then we are going to determine the directional derivative at the point 3, 4. So here also we are given the direction vector, and then we need to find the unit vector. So the unit vector u cap is said to be equal to the direction vector divided by its magnitude, and that is equal to 4, -3 divided by the magnitude, that is 4 square, that is square root of 4 square plus -3 square. That will be equal to 4 -3, or divided by, now 4 square is 16, -3 square is 9, 16 plus 9 is 25. So we have the square root of 25, and that is equal to 5. That is equal to 5. So we have this to be 5, and thus we have the unit vector to be, that is having components 4 over 5, comma, -3 over 5. Next, let's move on to the partial derivatives of the function with respect to x and y. So we have fx, that is equal to, now considering this function, we are going to differentiate with respect to x. So we differentiate this constant, we have 0, plus we keep 2 times the square root of y as constant. We differentiate x, we have 1, and thus we have fx to be equal to 2 root y. And then for fy, we differentiate with respect to y, we differentiate 1, we have 0, plus we keep 2x as constant, and then we differentiate square root of y. Now square root of y, okay, square root of y is the same as y to the power 1 over 2. So if you want to differentiate this, that is dy of y to the power 1 over 2, then basically you have 1 over 2 y exponent -1 over 2, and that's basically 1 over 2 times 1 over square root of y. So you differentiate this, and then you have 1 over 2 times 1 over the square root of y. We simplify this as 2 cancels out 2. We are left with x over root y. So that is fy. Next, we find the directional derivative, that's du f of xy is equal to, so we know it's equal to fx of xy times a plus fy of xy times b. So this is literally equal to, we have fx to be 2 root y, so times a, and then a is 4 over 5 plus x over root y, that is fy, times -3 over 5. So we have the denominator, a common denominator, to be 5. Therefore we have 1 over 5 on the outside. Inside of the bracket we have 4 times 2, which is 8, so 8 root y, and then minus 3x over root y. So basically we can say that this is the directional derivative at a point xy. So to find the directional derivative at a point 3, 4, we basically substitute 3 in place of x and then 4 in place of y. So that is equal to, we have 1 over 5 on the outside times 8 root y is 4 minus 3 times x, so 3 times 3 divided by square root of 4. So that is equal to 1 over 5 times, now square root of 4 is 2, so we have 8 times 2 minus 3 times 3 over 2, and that's equal to 1 over 5 times 16 minus 9 over 2. So we have LCM to be 2. 2 divided by 1 is 2. 2 times 16 is 32, minus 2 divided by 2 is 1. 1 times 9 is 9. So this is basically equal to 1 over 5 on the outside times, now 32 minus 9 is 23. So 23 divided by 2, and thus we have du f of xy, of 3, 4 to be equal to 23 over 10.